In this video, we are going to look at what happens when we raise a base to the 0th power and what happens when we raise a number, any base, to a negative power. So we're going to look at the why behind that. And without any further ado, let's see what this is all about. So I've given you this problem. It's very simple. A cubed, or a to the third, over a to the third. Now we know from our previous experience, when we divide powers, or full-on exponential expressions with the same base, we subtract the exponents. So this simplifies to a to the 3 minus 3, which is the same as a to the 0. And you might wonder, well, okay, so what is a to the 0? Well, this is the same number, right? A to the third over a to the third is the same exact number over the same exact number. And as long as these two numbers are not 0, any two numbers when divided by themselves is 1, right? If you divide the same number by itself, we get 1. So a cubed over a cubed is equal to 1, which means that a to the 0th power, which is equal to a to the third over a to the third, is 1. Now this continues to happen. If we have any base, I'll give you something like this, 2 to the 5th over 2 to the 5th. Well, again, that's going to be equal to 1. We know it is. It's the same number over the same number. But if we use our division rules, we subtract the numerator exponent minus the denominator exponent, and that gives us 2 to the 0, which we know is equal to 1. So any number, not 0, raised to the 0 power is equal to 1. We see that here now with our division rule. So in general, any number so that b is not 0 itself, raised to the 0 power is 1. So if I take any number, let's say it's 5.276, I'm going to make it negative, and we raise all of it to the 0 power, that's going to be 1. That's it. It's not so bad. Now, just a quick thing to point out, had I instead taken away these parentheses, like so, and I raise this entire gargantuan number, this decimal, to the 0th power, now the only thing being raised to the 0th power is the base, which is 5.276. Without the parentheses there, that negative is just kind of hanging out to the outside. We're not raising the negative piece to the 0th power. So this ends up being 1 with the negative on the outside. So we would end up getting -1. So just be careful, those parentheses mean a lot. Okay, now let's look at negative exponents, where they come from and what they mean. So looking at a pattern here, what I'm going to do is I'm very simply going to go through some powers that we know well. 2 to the 3rd power we'll start with is 8. 2 times 2 times 2. 2 to the 2nd power is 4. 2 times 2. 2 to the 1st power is 2. 2 to the 0th power we now know is 1. Now what is 2 to the -1? Well, to figure this out and what a negative power means, just simply look at the pattern of what happens when we add a power every time, but then we're going to look at what happens when we subtract a power. If we add 1 power each time, we're multiplying by an additional power of 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. But if we go backwards, instead subtracting 1 less power each time, we are dividing by 2 each time, which makes sense. We're going in the opposite direction of repeatedly adding or repeatedly subtracting. But what happens is, if we then subtract 1 off of 0, we get 2 to the -1, and we'd be dividing by 2 again. And division by 2 as a fraction is 1 over 2. And then 2 to the -2, we divide that by 2 again, well, that'd be 1 over 2 to the 2nd. Dividing by 2 twice, which is 1 to the 4th. Sorry, 1 over 4, or 1/4. So the idea here is that instead of doing repeated multiplication, if you have a negative exponent, you're saying do the opposite of repeatedly multiplying, which is repeatedly dividing by that power. Isn't that awesome? It makes logical sense. So the bottom line is, if you see a base raised to a negative power, you literally look at that and say, well, I'm repeatedly dividing by that base however many times this number tells me. Division is 1 over whatever that number is, right? If I divide by 3, that's the same as multiplying by 1 over 3. And if I divide by 3 squared, that's the same as multiplying by 1 over 3 squared. So I'm dividing by 3 squared here is what this is saying, or 1 over 3 squared, or divide by 3 twice. And that is equal to 1/9 when you simplify it down. Here, you're dividing by a to the 4th, or you're repeatedly dividing by a 4 times. So that would be the same as multiplying by 1 over a multiplied by itself 4 times. Now, there's a basic rule that goes with this, and it's not so bad. A lot of people teach it this way. They say when you have a negative exponent, you keep the base, but everything swings into the basement and the exponent becomes positive. So everything goes into the denominator. You get 1 over b to the positive exponent. But we've now seen why that works the way that it does. It's really saying the opposite of repeated multiplication is repeated division. Very cool stuff. Now, what happens when you have a base already in the denominator with a negative exponent? Well, now you're saying I'm going to divide 1 by something that's being repeatedly divided. Well, what's division by division? Well, if I divide by division, you're undoing that, it's multiplication. So this ends up being actually repeatedly multiplying by b to the n. A lot of people think of it as, if I see that negative exponent in the denominator, it goes into the numerator and becomes positive. That certainly is the trick, but we see why that works. It's division of repeated division. So now I've got a couple of numerical examples, well I guess just one where I have division by repeated division. This is 1 over 2 to the negative 2. So you can think of it as 1 over 1/4, or 1 divided by 2 to the negative 2, which is the same as 1 divided by 1 over 2 squared. So division by that division, if I divide something by 1/4, it ends up being the same as multiplying by 4. The division of division undoes itself, and you get 2 squared is 4. I think the quicker way to do this one, once you have the rule, is looking at this and saying, oh, okay, so that's 2 squared, which is 4. In a later video, we're going to go over some practice problems that will help you to exercise all the rules that we just went over. I'm stoked for it. See you there.